do a quick 3-minute video on simple post-estimation plots in Python. So once you run an OLS regression, you're going to want to take a look at the residuals, the U hat, and the fitted dependent variable, the Y hat. So let's take a look. So we're going to pick up basically where we left off in our previous video. We're here in our Python Jupyter notebook, and we're going to get some example data from the Federal Reserve. We're going to get the industrial production index, the unemployment rate, and the federal funds rate. Using our stats model package, we're going to estimate a simple OLS regression, and that's where we'll get our information to calculate the fitted residual and the basically the in-sample forecast of the dependent variable. Okay, so here's our regression results. Again, you'd want to spend some time looking this over, right, and making sure this is a well-specified model, which it's not, but just for the sake of our example, we're going to use this again to generate that Y hat, the fitted dependent variable, which in this case is going to be our industrial production predicted by our linear combination of our coefficients and independent variables, the Fed funds and the unemployment rate, and the gap, right, the distance between the actual industrial production, the Y, and the predicted value, the Y hat. That's going to give us our residual each period. So we're going to define that variable as U hat using the name of the regression, in this case, regression1, reg1 dot resid. Now we're going to use a simple plot, right, to give a kind of a visual diagnosis, right? So that's the matplotlib package, right, as PLT, and we're going to apply that to our U hat. So just again, a simple plot here will tell us a lot about potentially what's going on with our regression. So what you'll see here is increasing volatility of that residual and increasing size of that residual. So not surprising, production got a lot more difficult to predict, right, in 2020. So next we're going to get the Y hat, the fitted dependent variable. And we see it did a pretty good job, our model did a pretty good job of predicting, again, in sample, that recessionary impact of the shutdown and the coronavirus starting in 2020. And then lastly, we want to plot basically the ingredients to that residual, the actual path of output industrial production alongside what's predicted by our model. So that's what we're doing here. Again, just kind of rearranging the commands to generate that plot, and including a legend so we can identify which is which, and there you have it. So we have the predicted and the actual alongside of each other, and just for comparisons, that's what you're going to see in Stata, getting the identical results with the same data. All right, so I hope that was helpful. We'll be following up with more examples with this same data, and we'll see you next time. Thanks.